going to get along well, and at least we'll be able to look at the various aspects of data communication and, of course, networking. So before we go on to the topic of discussion today, I want us first of all look at the course outline, which I've already displayed, okay, on the screen. And of course, this should be data communication and networking, not just data, and not only just data networks. Should be data communications and networking. So that's a course code, which is BIT 323, and of course our semester is should be the first semester. Okay, year 2021, so 2022. Okay, should be semester 1. Year 2021. So the timing is as shown there, 5 to 7. And of course, we should be meeting in this today at 5 p.m. So what's the major objectives of this course is to be able to explain the fundamentals of data communications. And of course, describe the different media available to support communications. Now, if this is a good course, especially if you're going to specialize yourself in the networking courses, it provides that fundamentals of understanding what we mean by networking, as well as the fundamentals of understanding what we mean data communication, or how data is transferred from one machine to another via a communication medium. Okay, so it's a good course. It helps you to understand more on that area on networking. So basically, the overall kind of scenario is focusing on that aspect of networking. We're also going to distinguish between the conflicting usages of networking terminologies. That is, look at about the different concepts that regard about networks, and of course understand and explain the underlying network concepts. As I said earlier on, it's about networking, so it brings in that concept of what we mean by network concepts. Of course, identify key limitations in networking technology implementations. Now, remember, we are implementing technologies. We want to see what will be the problem with the different technology implementations, and how one would want to go ahead. Okay. Okay. So also look at one of the major models, which is called the OSI model. Oh, sorry. Before you can go to the models, of course, I'll look at the second last objective and the third one and the last one as one, because the OSI 7-layer model looks at the concept of protocols. Okay, and of course we want to look at what protocols are involved in data communications and how they work in. So that's what the course intends to achieve by the end of the semester. And of course, the course description involves different kinds of things that we're going to look at all this. For example, understand what you mean by data communication, what you mean by bandwidth, all those concepts that involve about data communication. Also look at the Nyquist theorem on Shannon and sampling theorems in form of how they relate towards data communication. And of course, look at the moderation techniques. That's both on data and, of course, digital moderation techniques. A very good example is the passcode moderation. And of course, look at data encoding and signaling, physical layer protocols, which involves about the aspects of networking, the data link control, and of course, multiplexing and of course switching. Now, all these are some of the major things that you're also going to focus on in this class. So in terms of a detailed course, of course, today I'm supposed to, if possible, look at 2 chapters. That's the area on introduction to data communication and, of course, computer networks. And of course, discuss about the protocols and architecture by looking at the OSI model, which is very important. And of course, the book which is a little bit good for us is this one here. If you can get this Baruch E. Fuzan data communication, okay, and of course William Sterling's again on data and computer communication. These are two books which are nice. So if you're able to get soft copies, although I'll be able to provide maybe the two online on our Teams. There are two good books which are meant to help us understand fully what we mean by the various aspects of these aspects of data communication. So you look at you introduce the concepts about data communication. We look at the protocols, and of course the other part we look at the data transmission by looking at some of the things that impair, for example, the data communication. Just give me a minute, please. Okay, so let's go on. Sorry for that. I was trying to answer some calls. So we have the data transmission media. In terms of, we look at some of the media which are normally used for transmitting data. Of course, we look at the guided and of course the unguided media. So the guided media here means they have to be in form of cables, okay? So we look at the different types of cables, how they transmit the data, and of course, we look at the unguided means the use of the different aspects, okay? The different aspects of the media itself, like Wi-Fi, Bluetooth, and of course, a satellite way of communication, microwave, all those which are never unguided, like and the cable itself, okay? So that would be in 4. Then now we come to data encoding. Remember, you have talked about how data moves from one computer to the other in terms of data transmission. You boost the media, then you look at how data is encoded or how it is put into a transmission means to be able to be transmitted across those particular medium. So again, that's a topic of discussion. Then we go to the area on data communication interface by looking some of the synchronous and asynchronous transmissions, and of course the type of errors that occur during data transmission and how they are normally rectified. Okay, so we also look at some of the means in which the data itself is it's avoided or is rectified. And then, of course, we shall look at data link control multiplexing. Now, here is how, one of the layers of the OSI model, which is charged the responsibility of ensuring that the data is transmitted correctly at all times. We look at how it does that. By looking at some of the techniques it applies, for example, in terms of what we call the flow control and error control, the framing, and of course other different techniques like the FDM and of course the WDM techniques, which involve in terms of data control. And of course you have the wide area networks, which involves about the congestion in data networks, and of course you also talk about some bit of switching techniques and signaling techniques, which involve about the way data is again moved from one location to the other. And of course it uses what we call some different switching techniques to be able to transfer data from one level to the other. So, and of course this will involve about lecture, and of course class discussion, and of course lectures. There are also a bit of labs that we're going to involve ourselves in, especially in terms of the code or the signal generation and all those kind of things. So we shall be doing some practicals. So as we go along, I'll be giving you the areas that you need to focus on, especially in terms of labs that we're going to involve ourselves in. So the textbooks that I've wanted to think about, I know these are a little bit old books, so I'd like you to look for the current books, for example, by Fuzan, and of course William Sterling on data and computer connections. So these are some of the two books which I would like you to focus on, and of course I'll be able to download some, and of course be able to put into our main link for us to be able to use them for our discussion, of course for our reference points when you are doing the reading for this particular unit on data communication and networking. Okay, so that in terms of in terms of the course itself, evaluation. Don't worry about these codes here. Okay, it's just the same thing. Just have it as one. I don't want to have it as both, whatever here. So basically this is for BIT 323. And of course for, I'm sure that this course is also identified with also the DIT one. So let me also put DIT 323. Okay, so of course you're going to have time papers, and of course this will be the assignments that you shall be doing, of course presentation and everything else. The cut will be out of 20%, and of course the exams will be 70%. So as you go along, that's how you're going to do the evaluation for this particular course that you're having. Okay, so I think that's all in terms of the course evaluation, and of course the next will be okay, the rules. Of course, the rules you already know, you don't have to keep on mentioning them. You can read them at your own free time to be able to work them out at your own free time. Okay, so sorry. Okay, let me try to put this one nicely. Okay. Okay, so that's how my exam is going to be like. So, so that's a course outline in terms of looking at the concepts of what you mean by networking. Also, the whole thing or the whole course that you're going to be focusing on in the area of data communication and networking. Okay, so now let's get ourselves to at least kick off this topic of this the course itself by looking at the first lecture. Okay, so so let's look at introduction bit of it, and of course some of these slides have been adopted from Behrooz Fuzan, just as a way of trying to help you also read the same concepts that you are focusing on in data communication and networking. So our major objectives today is to understand what is data communication and of course what is networking. And of course from that particular point, we understand why it is important to perform or to understand this course on data communication, and of course why networking, and of course what networking is in this case. So I'm going to start with the first objective, which is about data communication. So you understand what we mean data, and of course part of communication. And of course, this is in relation to computers. So it's my believe that all of us know what you mean by a computer, so I don't have to get ourselves into that level. The different components of a computer, and of course, you also know some networking devices that are required for us to be able to transmit data from one machine to the other. For example, like you know about what you mean by modem. That's my assumption. You should also have done something about what you mean by the NIC card, or the network interface card, and of course the transmission rates for those kind of cards. So here I'm really focusing myself on that area that you already know some basics of what you mean by computer, and of course how computers are able to transmit data across a network. So when you look at data communication, basically this term here is commonly used within the telecommunication industry. Okay, industry that deals with mobile communication, and of course the more of telephone industry. Let me look at it from the telephone perspective. Okay, it has been adopted in the computing field, mainly because of the integration of or the initial integration of telecom technology towards the computer technology, merging together to form that interface of sending and receiving data across a networked environment. So in telecommunication, basically it adapts that part of sending and receiving of data across or maybe at a distance. So the word data refers to information. Of course, you already know about that. Presented in whatever form, in a grid form by parties executing and using, of course, the data itself. So data, of course, can either be in raw form or it can also be in processed form. And of course, the moment you process it, it becomes more of information. So data communications is, if you look at the now those two terms, you are trying to do, sending data from one location to the other over a distance, and of course you are transferring something that you have already agreed upon in terms of what you're going to use it for. Then of course data communication, we can think of it as more of that exchange of data between two devices. Now, this time around, it's not between people, okay? It's between two devices. And of course, those devices must be in a networked environment. Network means that those devices must be connected together to be able to exchange the information that is, allowed to be exchanged between them. Now, this connection of these devices, of course, must be via a transmission medium, such as a wire cable, okay, or even satellite, or maybe, for example, microwave, transmission, of course, in terms of Wi-Fi or even Bluetooth technology. So that perspective or that aspect of communication, that it means that exchange of data, and the exchange, of course, has to be two-way, okay? It's not always one way. Of course, there's one way of communicating, but in most cases, especially in modern times, we are focusing on two-way of data transmission. So in this concept, then you need to understand what will be some of the components that is required for us to be able to understand what you mean by that data communication, and of course how data flows. Okay, when you look at data communication perspective, how does that data move from one location to the other? So if you look at any component or the components that are used for data communication is as shown here. And one of them is the protocol. Okay, so before we can come to the protocols, you have the two devices. Now remember, you say that data communication involves two or more. Actually, I should be able here to say two or more devices. Okay, it's not only between only two devices. So I'm looking at it in terms of two or more devices. So you have the sender, the person who is the originator of the information or the data that is going to be sent. And of course, you have the receiver on the other end. It could be a distance, or it could be maybe someone who is next to you. And of course, there's a medium that is you're using to be able to, to send your data. And of course, inside the medium that is going to transmit the data, we have the message itself. Now, in this message, there must be rules that are governing how that information is being transmitted from the sender to the receiver and back. So those rules, of course, we call them the protocols. So in any environment of data communication, it involves these four major components, okay? That is the protocol, the sender, the receiver, the message, and the medium. So that is some of the major components that we need to think about. So in fact, when you look at this particular course, it involves itself in terms of this diagram here, okay? For example, if you talk about how data is being sent from one level to the other, we shall be focusing about the medium. So which medium is supposed to be used in terms of data transmission. If you look at the message itself, how should it be encoded? For example, in this case, if you look at the protocols, which protocols are facilitating the transmission of data from one end to the other? And of course, which protocols are ensuring, for example, in case of an error, how is it handled in terms of that bit of data transmission from the sender to the receiver? So basically, that's how this particular system is, and of course this is how it's supposed to be achieved. Okay, so in data communication we have those major four components for there to be transmission taking place between point A to point B. Now when you talk about communication, okay, it's good to see that we need to see the different ways in which communication takes place. Okay, one is what you call simplest, or the simplest way for data transmission. For example, between maybe the server to your computer. Okay, that's one direction. And of course, it provides us with the simplest way of doing this. For example, when you try to access your portal, when you go to the website, you access the portal and you receive the details from the portal. Maybe you wanted to check your results. Okay, so there's that one direction. So you're getting information from the server, and of course, getting it to your screens. Now, there's no much of that. So information just be relayed on one direction. You're not doing it in terms of giving a feedback to the computer, the server itself, to be able to respond to you. So basically, here it's much more of a one direction. Then, of course, you have what you call the half duplex. Now, half duplex is whereby direction is normally of data is on two ways, yes, but of course it has to wait for the other station to be able to receive it and be able to respond to what you are doing. So basically you have to wait. So it has to receive, it receives, it processes the data, and of course it gives back maybe a feedback. That's why you're talking about data or direction of data time one, meaning it moves from station one to the other station. It's processed, and of course from station the second station to the first station moves at another different time. So there's no kind of a lead time kind of environment. But of course, when you look at modern systems nowadays, they are more on a real-time basis as opposed to the half duplex basis. So when you look at it from this particular point, is that most of the devices are now focused, or they're now based on what you call the full duplex. Full duplex meaning that the direction of data is now on both ends. Okay, so you don't have to wait to process the data. You can still be responding to certain kind of information as you still receive some more information. So in this case, this is very important. This case of full duplex is even seen, especially when you're working with your social media platforms like WhatsApp. Okay, you'll be receiving some messages as you still type. Okay, and of course you'll be able to be sending reply. You don't have to wait to receive all the messages and then you keep replying to them one by one. No, you can still be replying to them as you still receive some more. So in this case, when you look at full duplex, most of the systems are not on half duplex or simplex. Now, whatever could be half duplex could be like, for example, like the walkie-talkies, the police walkie-talkies. So the police walkie-talkies, they will be more accommodated in this aspect of half duplex, meaning you have to talk, then once you talk, you say over, then the other person listens, understands, then of course replies to your message, says over, and then you keep on doing like that until the conversation is ended. So there's still some few devices which are still on that half duplex, but not many. And of course, these are limited in terms of the distance. If you look at half duplex communication, it's normally focused on a certain region. It cannot go beyond a certain region. If it goes beyond a region, of course, the signal is normally lost. Okay. But of course, when you talk about full duplex, of course, the distance and of course the region of it's expanded, of course, and of course it expands to a certain to a different kind of a region. The wider, so the region that's being covered on full duplex is a little bit wider compared to the one for half duplex. So those are some of the ways through which data will always flow between systems. And of course, our major focus will not be on the half duplex or the simplex, because most of our systems now are focusing more on the full duplex. So when you shall be talking about data communication, yes, there are three ways through which data will flow in, in a networked environment. But of course, our major focus will be those systems which are, focusing themselves on a full duplex basis. So that means in terms of data communication, there has to be a way. Okay, when I looked at the data communication perspective, we talked about the medium. But of course, you can see the medium is connecting. So this connecting brings in the aspects of network, okay, or connecting the two devices together to be able to form a small network and be able to transfer this data from point A to point B, and of course, transfer this data, towards the system. So basically, from that particular perspective, it brings in the aspects of a network, okay. So from a very basic understanding of what we mean by a network is that set of devices, okay? In networking, we normally call them nodes, and of course, which are supposed to be connected by communication links. Now, these links could be either cables or could either be guided media or unguided media. So this set of devices, then that means they must have a way of, sending and receiving data. Okay, so if you talk about your computer, it must have that port that enables it to be connected to maybe a physical networking medium like a cable. Or if it has an internal modem, then of course it's able to receive Wi-Fi communication. Okay, and of course, those are some of the devices that you shall focus on later when you shall be focusing in terms of how the communication takes place between point A all the way to point B. So therefore, a computer can be a computer. So a node can either be a computer, a printer, or any other device, maybe a mobile phone even, device which is capable of sending or even receiving data, which is generated by other nodes on the network. So the link on this case I said earlier on could be cable, air. Now remember, we talk about air, I'm focusing myself in terms of the unguided media. In this case, we're looking at, for example, like satellites, microwave, Wi-Fi, Bluetooth technologies, and even Li-Fi, which is also another kind of technology which is being involved for data transmission. Optical fiber or any other media that can transport or signal carrying information. Okay, you see, for example, like aerials. I've heard about aerials. There are different kind of aerials nowadays. If you look at it from the point of like DSTV, if you look at the area for DSTV or that dish for the DSTV and compare it to the one for the GoTV, they are different. Okay, and in fact, in terms of their data transmission is also different. Okay, one will use satellite communication, the other will use radio waves. Okay, so again, we shall look at those different means through which network or through which computers are able to send and receive data across a network. So in here, we want to look at what we mean by the network itself, the criteria, the physical structures. Okay, physical structure means how the planning of networks takes place, or the different plans that can be offered in terms of creating a network, and of course the different categories that are there for there to be a network environment. Before we can get ourselves to another topic that regards about the issue of a networking environment. So when we talk about network, some of the factors that one need to consider, especially in a network environment, is these three major ones here. One is the performance, second is reliability, that is security. Now, when it comes to the performance, performance is basically measured in terms of the delay and of course the throughput. Maybe when you shall be talking about the Nyquist and Shannon's theorem of network performance, we shall be focusing on that maybe later on. We try to see, for example, what does it mean when you talk about performance? When you say, for example, my signal strength is low, and of course you're not able to send and receive data. Basically, it shows that that performance or the performance of your network is not good. If you come to a point whereby there's a Wi-Fi router, for example, you find that it will be able to send and receive data very fast. If you now start, moving away from that particular router towards a short distance, and of course the performance also decreases. So what is it exactly is happening behind the scenes that makes your network performance to become either poor or even better depending on your locality of, for example, of the Wi-Fi router? So there will be different kind of elements that will affect the performance. Also, maybe the devices that you're also using, they could be faulty, or maybe the transmission mode that you're using is also could be of lower strength in this case. So there will be other factors that may affect your performance of your network, and of course those elements can either be rectified or can be done something in terms of either replacement to be able to make your network become even better. Two of the criteria that you also check in terms of your network environment is the reliability. How reliable is your network? And most of us live in the hostels here. Okay, how many of us live in the hostels here? How many of us are okay? Mirambi, anybody else? Oh, the rest ni watu wa kujipikia huko Karinde.
Huko kwetu. Nasomea nyumbani.
Unasomea nyumbani, unapikiwa? Au umeshapika? Wapi?
Bwana nipikia.
Okay, sasa anyway. So if you are in hostels around here, of course, one of the things I understand is that the network is not very good. Okay, so I saw some network Wi-Fi's around. So I don't know, when you tell me there's no network, it means that people are not able to access the Wi-Fi connectivity. So that means, for example, the reliability of those softwares is not there. Also, not the software, the reliability of that network is not good. And of course, the failure or the reliability of this can also be caused by other aspects of it. Maybe the failure of those components or the networking components are not very reliable as well. Okay, they may have failed in terms of getting or receiving the signals from the point of connection towards your hostels, for example. And of course, that forms the concept or the quality measure of a network to be poor in terms of reliability. Okay, so here it means in terms of availability and of course the robustness of that particular software. Sorry, not software, of the network itself. So robustness is if I came here at night at midnight, will I still find the same service as I've been finding right now here? And if it is going to be, then of course it's going to be important for me to have that as robustness of the system itself. Then of course you have the security part. Security part is important because we are talking about data being transmitted from point A to point B. Then of course you need to have some mechanisms which have been developed to be able to secure that data across a network. And of course, we also secure our data from different kind of things. One is about the errors that may occur. You don't want to have a scenario whereby data is being transmitted from point A to point B and it's full of errors, okay? So that retransmission again to cost you in terms of the bandwidth, because remember, in terms of transmitting of data, it's not just transmitted, it has to have what you're calling the bandwidth to be able to transmit the data. So it's going to cost you. So you don't want to have a network which is so much error prone. Okay, so you want to have a network which is error free, and of course it has the performance is also going to be good in terms of if you have error free in this case. Then of course you also protect your data from malicious users. In networks right now you're talking about connecting ourselves to the globe, okay, through internet. So most of the services now are internet-based services, and of course that transmission must always be protected from malicious users. Users will always think about how to steal money. Okay, if you're, for example, you're doing the internet banking, okay, and so on and so forth. So basically, from this particular perspective, these are some of the three major factors that you need to consider when you talk about a network services. So the services must be measured in terms of the performance, reliability, and of course security. Okay. Now, when you look at connectivity or network environment or the physical structures in network environment, one, you need to think in terms of two things. One is how the computers or the devices are being connected together. So here brings in the kind or the type of connection that you're going to carry between these two devices. So of course, we don't connect there has to be the manual connection, of course, laying of the cables, connecting the devices, and so on and so forth. But of course, you also have what you're calling the multi-point, okay? The physical topology in this case. So in this connection, you have the point-to-point, which means there's a single transmitter and receiver in this case. And of course, this kind of a network, we normally call it as a peer-to-peer network. Just like the same way that you have your phones and you want to share your files from your phone, you'd use, for example, Bluetooth technology to be able to share the resources that you already have. So there will be that kind of aspects that you need to focus ourselves on when you look at the aspects of what you mean by point-to-point. Now, when you come to the multi-point, of course, here you are talking about using a single transmission or multiple transmission, of course, having multiple recipients, okay? So again, here, the infrastructure again changes from just a point-to-point, whereby you can have a peer-to-peer network to what you're calling a client-server architecture. And of course, a multi-point connection brings in the concept, especially in terms of modern networking, it brings in the modern aspects of what you call the client-server architecture. You have the server on one end, and of course you have the client, which sends a request to the server, and the server responds that to the client machine. Then, of course, when you come to the second aspect of these structures, of course, you have the connection. You also have the topology. Physical topology means the physical laying out of these devices, the connection itself. It can be either point to point, but you need to see the physical connection. If I came on the ground, I'll be able to see this cable runs from this machine to this other machine via maybe a switch. I'll be able to see all that. That's a physical connection. So when you look at the physical topology, topology means the planning, okay, or the plan itself, how it looks like on the ground, how those connections has been taken place. So if you're looking at it in terms of point to point, I'd like to see how physically they have been connected. You should be able to see a cable coming from one machine to the other. So in the physical topology, we look at what we mean by the connection of devices. Okay, so connection of devices is important. That physical connection, you should be able to see it physically connected. And of course, on the other end, from a logical perspective, we look at the type of transmission. Of course, you're going to look at this kind of transmission. And here it brings in the aspects of, for example, like, are you going to unicast? Unicast means you only send it to one machine, okay, and receive the information. There's also multicast. Multicast is whereby you send that information to different machines which are only referred to, okay, in that message. And of course, thirdly, you can talk about in unicast. So broadcast. Broadcast is you send to every device which is connected in that particular network. And if, for example, that information belongs to them, they receive. It doesn't belong to you, you discard it, okay? You discard that particular information. So, so in that case scenario, that's what it means to have the different connectivity or the different physical or the physical structures in this case, not looking at it from a logical perspective, but what you mean by a network itself must be based on these two major perspectives, the connection and of course the topology. I hope you're together. I don't know if I'm rushing or you're understanding. Any questions so far? Are you okay?
Yes.
Okay. So I hope that yes for minor is for everyone. Kwani kuna mtu ako barabara? This Peter. This must be Peter.
Yes, sir.
Are you on the road?
Niko nyumbani. Ni maji.
Okay, sawa. Okay, sasa kwani kwa shower? Anyway, let's go on. That's the beauty of online learning. You can learn it even when you're swimming. Anyway, let's go on. So we have the physical structures. So the other part is understanding about the connection. Remember I talked about the connections. So this is just much more of a way of helping you understand. So you have a single link. And of course, you're talking about from one point to the other. So if you're having about stations, in this case, you're talking about the computers, you have a point to point. In this case, for multi-point, of course, you're looking at it from the different single link. And of course, you have different station linked to the same link, of course, served by one machine, which is going to be able to service all these kind of scenarios. So in most cases, you don't have what you call the station point to point, but point to point will be there, especially if you're looking at it from the point of Wi-Fi connectivity, that you don't require to have that physical connection. So you're only connecting yourself to the Wi-Fi router. Of course, the Wi-Fi router services you in terms of services. But of course, if you look at Wi-Fi connectivity, is more like a multi-point, okay, as opposed to a point-to-point. A point-to-point must be two machines close to each other, and of course, sharing the information given to them. So when it comes to topologies, I said earlier on, is a physical plan in which we're able to see how physically the machines have been connected. Of course, it comes into four, and the fifth one is more of a hybrid. Hybrid means that you combine either two or even more of these topologies. So we normally have what we call the mesh, the star, the bus, and of course the ring. Later on, shall be focusing on how data is transmitted on each of these topologies, because the mode of transmission of data in each of these is different. For example, when you look at a star or even a ring, is very different from each other. So when you look at these topologies, one is the mesh one, and of course you can talk about different stations, and all of them are connected to each other. Okay, this is normally depicted, especially when you talk about the internet. Okay, internet is more of a meshed kind of a topology. Okay, it uses the mesh topology to be able to transmit data from one point to the other. Okay, a mesh topology. Now, you can see from this here is that each and every one of them is connected together. So if you look at it, there's a multi-point kind of connection. You can talk of this as a single connection, yes, because all of them are connected with each other and to each other. And the transmission is, if you went back, there's that part, it could either be broadcasted, okay, from station one to the other station in terms of broadcasting, or it can be unicast, okay? You can send from one station to the other, or you can send from one station to all stations in this case. And whoever message applies to, of course, it can be received, and of course, the rest discards the information given. So this is just a physical plan of how the machines can be connected with each other. So giving us what we call the mesh topology. Then of course we have the star topology. Nowadays we don't have the hub. We currently use the switches, which are more intelligent compared to the hub. Okay, when you talk about intelligence, means here in terms of they know where the message is coming from and where it's supposed to go to, and of course does not confuse who sent the information in case of a feedback, and send that information towards a different station. So basically here you're talking about a switch, not a hub. And of course, a hub is meant to connect all the four devices. Okay, like in this case, you're talking about four stations. And from the if, for example, if you are here in campus, of course, you could have done maybe a star topology and see we connect like four devices together using a switch. We see we create a small network, okay, to be able to see how the information is able to connect with each other. Okay. But now, since you are far, we shall have to do it more for practical side of it and be able to connect different devices, be able to provide the that connectivity maybe on from a logical perspective. Okay. Now, we look at a bus topology. Of course, this is what happens. We have a single medium of transmission with the cable ends being terminated. It could either be a fiber optic cable or it could be either a coaxial cable. Mostly those are the two cables which are normally used for this kind of topology. And of course, you have a drop line. Now, this drop line, it uses what we call the T connector, which connects the machine towards the cable itself. So this means if the cable itself is has malfunction, of course, the network does not work. Okay. So you have different stations, all of them connected towards that particular part, and of course, it brings in the aspects of how data itself is, moves from one machine to the other. Okay, so bus topology is a nice one, but of course, in case the cable gets malfunction or it's broken, in this case, the whole network has to be reshaped again. So in most cases, you find people, they either do this kind of a startup point because it's easier. Okay, in this case, you normally find, for example, the hub is the one which is failing, so you just have to replace the hub. Now, this one, you can imagine, redoing the cabling. Cabling means that you have to redo the cables, the network cables. Okay, it's a little bit tiring, I suppose, done for the star topology. Now, on the other end, you have what you call the link topology, which is connecting different kind of stations. You can see we have different kind of other devices inside there, which are calling a repeater. So basically, a repeater is meant to, one, to enhance the signals strength from one device to the other. And secondly, it's also meant to provide permission of transmission of data. Now you realize that in this case scenario, you can have any particular device sending and receiving data. So in this case, there's that way of controlling who is sending and of course who is trying to, who is controlling the transmission of data or sending, especially in terms of sending of data. So in this case, this repeater also tries to identify in case of any collision of data in the network itself. And of course, the technique that is normally used here is what we call the carrier sense multiple access with collision detection and collision avoidance. Okay, that's a technique that's normally used in a link topology to be able to avoid this kind of data collisions. Okay, in this kind of a network environment. The technique is also known as carrier sense multiple access with collision detection and collision avoidance, CSMA/CA/CD. Okay, so that's the technique that is normally used, especially in a link topology, to be able to connect the different machines you're talking about in this environment. Then, of course, as I said earlier on, you can have a hybrid because we are having a star as one of the, or a hub in this case, providing like a star topology. But of course, we are looking at it from the point of a bus topology as well. So we are using the backbone. The backbone is star, okay, that is connecting all these together. But of course, we have three bus networks connected with each other. So we have one connection to the hub, or three connections to the hub. But of course, we have the cables themselves running to be able to support the different machines. So this is a most of what you mean by a hybrid, and why most institutions will try to do the hybrid is because of looking at the advantages and of course maximizing the advantages of each, okay, to provide a better performance. Remember, I talked about the three different criteria that one need to look into when talking about a network. Of course, in this case, you look at it from the point of what is the advantages of us combining these two network topologies to be able to provide better services for our clients, who are the customers, of course, and even the employees in an institution. So this is a hybrid topology, and of course, this brings us to the concept of understanding what we mean by the different ways through which you can structure a network. So a network will be structured, and of course, the other means will be how do you transmit the data from point A to point B, which will be the mode of transmission, which will be the medium, and of course, which techniques is going to be involved. And of course, having these different kind of topologies also provides the different ways through which you can choose the different kind of techniques to be able to provide for this environment. So when it comes to categories of networks, networks can be categorized based on where they serve, okay, in terms of the geographical location that they are meant to provide services. So if you look at a local area network, basically they are more of a local environment. Like maybe like this building here, like the faculty building, maybe the building that where our labs are, providing it within a short distance. And of course, in that case, you may want also to choose the kind of cable that you want to have to to be able to provide that connectivity between local area networks or the device that you already have in that particular location. It's also designed to provide local interconnectivity. It's not meant to go very far. If, for example, you have a network at home, it's not meant to share that network with your neighbor, for example. If you share with your neighbor, no problem. I don't have a problem with that. But it's mainly meant for your home vicinity. Okay, so you're able to connect. Maybe if you're in any particular room, you'll be able to go and connect yourself to any particular room that you have. And also, you have what we call the wide area network. So the wide area network here provides us with long distances. And of course provide connectivity over large areas. So this, of course, is going to go beyond maybe the local environment, okay, beyond the country, for example, beyond maybe the region that you're talking about in this case. So it's a wide area network. And of course, the metropolitan area network, it will provide connectivity over areas such as a city or even a campus. Okay, so it's more of a RAN. Okay, it covers a larger distance than local area network, but of course it's a little bit shorter in terms of distance when you compare it to the wide area network. So like I was talking about, the half duplex ways of data flowing, and of course I talked about the police. So if you may look at it from a police perspective, their stations, maybe there could be those which are found within Nairobi area or the Nairobi metropolitan area. So the network for the police maybe stations is only based on the metropolitan area network or this particular city here. If you go beyond the city, of course you will not be able to get the connectivity, you will not be able to get the communication. If you look at it from here in a campus may also mean in terms of if you have many buildings, and of course all of them are connected. They could have like the hostels, the faculty building, the CMC, the staff houses. What else? The cafeteria, all those areas which have been covered by AIU. Of course, the connectivity here, it's more of a centralized location. Okay, so that network is basically meant for those people who are residing in that particular location. And that brings in the concept of what you're calling the metropolitan area network. Okay, so it covers a longer distance than local area network, but of course, not as compared with what we have in terms of our wide area network. So in this case here, it's much more like a case of of a local area network. I think this one can now give you a scenario for our labs, isn't it? Are you seeing our lab here? Okay, so our labs will be much more of a local area network connections. So you can see you have different machines like here, there are 12 computers, okay, and of course you have the closet, maybe what you call the patch panel for the different devices, for example, like what do you call this? The switches, okay, in the labs, and all of them are being connected to that particular location. So you can see all of them have been connected to the different ports of our switch, okay. So this forms what you call an isolated hub, or isolated because it has not been connected to another maybe environment or another lab, for example, in this case. So this is just an example of what we mean by a local area network. Let's talk about the wide area network. Now, when it comes to the wide area network, it's a little bit different. If you look at this one here, the device that you're looking at here is only the machines. If you look at it, if you're looking at it here, talking about the guided media, like the cables, you also have the switch, and all these machines have been connected to the switch, okay? But now, when you come to the wide area network, since you're covering a wider location, of course, we have now another system, which is now assisting in terms of, connecting the different kind of networks in different locations. And this is what you're calling a switched. So remember I talked about, we shall look about the different switching techniques. So in this case, it's providing to us, using a switched network or switched wide area network, it's providing to us the different connectivity. So the edge system here is not only one, it's not only one machine. It's connecting, for example, different local area networks. Okay, so when you look at this environment here, is providing us with in one here. When you talk about the end system, it's not only one machine, but it's covering, like example, like now this local area network, okay, with different machines together. And of course, you're using the switched wide area network to be able to provide that connectivity. Now, This was more common, especially in the telephone industry, when you used to have the booth, okay, the telephone booths, okay, whereby you, in a region like Nairobi, you have several booths, and of course they're being served maybe by several number of switched or PABXs, the private exchange branches, okay. They used to be called the private branch exchanges, the PBXs, to be able to provide, that switching techniques between the different booths that are going to provide the communication. Now, that has been now reiterated in the environment of mobile communication. And of course, the integration of mobile communication with computer networks, it brings in again the aspects of the switched network. So still, we are basing our networking on the old models of telephone. Of course, there have been improvements in terms of the performance, in terms of newer technologies to ensure security of that data is still new, but the infrastructure is still based on the old telephone system for sending and receiving of data. So that's much more of a switched wide area network. And of course, this is what I was talking about, a point to point. Okay, you have two machines, of course, and of course we have that connectivity whereby there is the sharing of information, and of course the exchange of data as it takes place between the two devices. Okay, so this one brings us to, there's no like switch, there's no like there's no like the hub or the switches themselves, there's no PABXs, just that connection directly to another device and of course be able to exchange the different kind of data together. Now here is more of what we call a heterogeneous network, which is made of 4 ones and of course 2 local area networks. You can see at the bottom here we have a local area network. So when I was talking about, if I may go a little bit back, I talked about, when we talk about the end system here, we are mainly focusing on the different local area networks that are being combined. Okay, so there'll be several of them. So you could have like 20 here, 20 the other side, 20 the other side, making extending the services of a wide area network to to a wider region. Okay, so if you look at it now critically here, you can see we have, for example, the local area network down here using a bus topology, the other one using a star topology. You connect it using a router. Okay, the router connects itself to what? To a router, to another router. So basically, this is meant for this network here. Sorry. Okay, on this other end, we have now the switched wide area network, again connecting with this other one here on this other end using different devices like the routers. And of course, you have also another somewhere who is also doing maybe a point-to-point connection. Okay, so you can now see a heterogeneous way of connecting, maybe based on this diagram. Of course, you're going to do one which is ours and be able to connect different devices using maybe packet tracer for our case scenario here to show the connectivity of devices between the different machines that you already have. Okay, so basically this is what I'm trying to mention here in terms of understanding what I mean by that connectivity of devices, okay, between different, and of course providing us with all this. So with that idea now of how different topologies are being connected with each other, you can now see if we move ourselves from just a wide area network to even a wider one, okay, which we are now going to call a global area network. It provides us with what you're calling the internet. So basically, the internet now comes in, and of course, it provides even a bigger infrastructure where now the applications can reside in, and of course, the services, different kind of services can also reside in, and of course, different systems will be able to provide those services, and of course, connectivity to be able to provide all these services. So the internet, of course, brings in, and of course, the infrastructure of a local area network towards the wide area network to metropolitan to global brings in the infrastructure on the internet itself. So if you look at internet, I normally look at internet as more of a physical infrastructure, which combines now the several wide area networks together to be able to provide that connectivity. And of course, you look at it as a communication system, and that communication system is meant to provide even more services, okay, which are not being provided by other environments, okay. So with internet, of course, it provides us with that aspects of providing the different aspects of different things across the globe. So that is what we mean by the internet, and of course how internet is working is based on those two. So in that section, let's look at, we understand what we mean by the organization of internet, because again, when we shall be talking about data communication and networking, we're not limiting ourselves to only the local area network, but of course we're looking at technologies which are also based on the internet environment. So we're looking at it from a bigger picture. So data communication and networking, you're going to focus ourselves on the bigger picture, which is based on the internet itself, and of course the technology which are using on the internet, they're also being used in the lower levels of networking, which is the local area network. So if you look at this structure, okay, this is what normally happens. You normally have what we call the national ISP, or the key body that deals with the service providers or the internet service providers. Then you have the regional ones. You have what we call the local ones, the ISP providers. Okay. So if you look at this national, what do you call it? National ISPs. Basically, I think we have like 13 national ISPs across the world. And of course, these are the ones who normally now provide the services towards the regional ISPs. Now, when you talk about the national ISPs, think about the developed countries. They're the ones who manage these national ISPs. Okay, then of course you come to, for example, like Africa region, and of course from Africa region they now go to specific countries. Okay, like here in Kenya, who be the providers of that particular service. They come, for example, like Safaricom or Telcom or Zuku. Okay, or maybe which one? There's several other different kinds of ISP providers. Okay, so if you look at that structure, then that means it starts all the way from the top there, and of course the top there has to link using different kind of systems. For example, like the satellite systems. Okay, to provide all these regional ISP with data services. So so you can see networking is not just from the local perspective, but also gets itself to the top level, which you're now looking at it from the national ISP providers, towards smaller networking environments. Okay, so that's again is why we get ourselves to in terms of regional ISPs. So in this case of what internet, okay, what you normally have is protocols. Now, when it comes to the protocol side of it, internet is guided by these protocols, and of course you are sure of these protocols. For example, when you access your internet, let me just maybe try to look for someone here. Okay, so maybe let me say AIU.ke. Let me share it with you. Okay, so let's come to our site here. So when you get to your AI.ac.ke, you normally find this. Okay, this is your URL that you normally put there. But if you want to know much about it, of course you normally click on that particular icon. Okay, for the padlock, and of course it gets you more information about the connection that you're having. Of course, it tells that the connection is secure. If you want to learn more, you can load it and of course learn about what you mean by secure sites. Okay, and all that. So my case here was more of this. Okay, and of course you can get to know the site settings. There's something more I wanted to show you in terms of the protocol that is being used. Okay, it's not here. Something I wanted to show you. Let me see. This is what I want to show you here. If you look at this section here, okay, which is now common to all of us, I know you know it. For every website, you don't have to type it. Okay, initially you used to type it for you to be able to connect yourself to the internet, but nowadays you don't have to type it. Okay, I hope you're concentrating. Don't look at these pictures which are on that. I know most of you are now looking at the pictures. Are you concentrating? Anyway, so you have this protocol here, which is HTTP, which actually defines how all HTML-based kind of websites will be, will be put onto our screens. Okay, so this protocol here, which is the HTTP protocol, is meant to provide that guideline. It's meant to show us what exactly this section is about, or providing us with a service of giving us the solutions towards this part. Anyway, so our key area here I wanted you to understand is about this protocol. Of course, there will be different kind of protocols. You're going to see them later on, which provides us with the guidance towards this. Okay. Something else I've noted. Dennis, are you there?
Yeah.
Okay, now this website of ours, why is it that there's so many of female students? Why are the gents? Why is the boy child?
Well, their faces are attractive. We need
Huh?
we need the attraction. The attraction.
Aye, my friend, Bana. This is
Aye.
not gender. There's no gender equality here.
The site is not for gender equality. It's for attraction.
For attracting.
Yes.
Aye, my friend.
Ai, kwani sisi watu mwalimu?
Si unashindwa?
Well, hatukatai hivyo ni na human, lakini only attractive and the others.
Aye, my friend, I think we need to do something about it, to be all inclusive. Like this one is just like 94% ladies, 6%. Hey, okay. Anyway, Dennis, we shall talk about it later on. With Jared, I think this one need to be rephrased also. But I don't know whether they are going to agree. But again, no. The boy child has been denied their chances as well. Just kidogo. Just give me a minute. I come back, please. Just give me a minute. I come back. So sorry for that. So let's go on. So also in the point of the internet, and of course you're talking about the protocols, okay? And of course the protocol is synonymous with the rules. Of course, when it comes to the internet, you need to look at those rules, how they are normally formed, of course, in terms of how the communication takes place using these different kind of protocols. And of course, when we shall be focusing on the OSI model, it shall help us to look more in terms of those protocols and of course how they function. So in this case, you want to look at the syntax, the semantics, and of course the timings for these protocols, and of course how they they facilitate in terms of communication. So one, when you talk about protocols, you need to think in terms of the following things. One is a syntax. Just like in programming we always talk about semantics and syntax. And of course, these programs have been formed in terms of the way the system is supposed to work. Okay, so in this case, when we talk about syntax is how the protocol is supposed to, or the structure of the protocol itself and how it has been developed to be able to perform certain kinds of functionalities. So the syntax here provides us the structure, the format of the data, okay, how data must be presented. For example, when you look at HTTPS, it defines how data must be presented on your screen, okay? So it provides that kind of a format. And of course, it indicates how to read the information which is being sent from one level to the other. Then you also have what we call the semantics. Semantics here provides us or gives us an interpretation, the meaning of the different sections of the codes, for example, in this case. So semantics here provides us with that aspect of understanding how to deal with, the whole thing of understanding the protocol itself and its functionality. The timing, of course, it gives us how data was sent and of course how data was received and so on and so forth. Maybe can all of us do some practicals a little bit for this part of the protocol, and maybe I'll go to the command prompt whereby you can try to understand this more. Allow me to share this. Okay, maybe to just help us to understand this section. Okay, so I'm using this and I want to just look at maybe get myself to what? To the website aiu.ac.ke. Oh, sorry, I'm supposed to ping www.aiu.ac.ke. Let's see what's going to happen in the ping part of it. It's going to request timeout. Most likely they have hidden it so that people don't just get it. Okay, anyway, the most important part is this part. Okay, so you can see it's showing me the communication or the server that I'm trying to communicate with, which is the AIU. That's the server that is there. Okay. I wanted to see whether it's a way that I can connect even with Google. Let me see. Okay, so you can see, for example, in this case, it's giving me some ping statistics that I was trying to communicate with this particular machine here. It sent four packets. The received was 0 and the lost was 4. So it gives me 100% loss. So this is a protocol. Okay, Packet Internet Grouper is a protocol which tries to establish communication between two devices. So I was trying to communicate with this particular website here, okay, but which is 197.136.17.10. Of course, it sent 4 protocols, it received none, and of course the loss was 4, giving us 100% loss. Now, this is the format I'm talking about. As a protocol, what does it do? It's meant to establish that communication between the two devices. If there's no any communication, it's supposed to send 4 packets. So for example, in this case, the part of request timed out is one of the packets. All these are 4 packets. The request timed out, all those 4 statements that you're able to see there, there are 4 packets of a certain byte level, okay? And of course, I want to see whether I can we can be able to communicate with. Let me just see whether I can do that. We ping 197 again. Dot 196. Maybe this time already to work. Dot 17. Dot 10. Dot 10. Give me request timed out. Let me see. Nothing much. I want to see which one can give us more results. You can see I'm now pinging another one device here. This is for Google. This is IP address for google.com. So give me this timed out. Dennis, what is your IP address on your machine?
Just 172. Dot 16. 64. Dot 70.
Okay. So let's see if I can ping a machine. 172.16.64.70. So give me a request timed out. Okay, let me see something else, maybe ping. Good. I tried to ping myself. Okay, this is what I wanted you to see. The differences between the way you can, connect. Okay. And I use this is what you call this. I forgot the name for it. 127.0.0.1. What do you call it? I've forgotten. Anyway, I'll come back to it when I remember it. So basically, this is a ping command that you're trying to ping this machine here, or my machine here. Try to check whether there's any connectivity with itself, and of course, you're able to see it's giving me how many bytes. 4 bytes. Sorry, 4 packets. So there are 4 packets which were sent, and of course, it received 4 of them with a loss of 0, giving us a 0%. Okay, and of course, you can see it also giving me some approximate round trip times in milliseconds. Okay, so also it had also the time for living within that particular section for doing this, which is 128. Now, this is a response which has been deployed by this particular packet, sorry, protocol, which is a packet internet grouper. So every protocol has its way of the syntax, that's a format itself, the semantic, the meaning, and of course the time that it takes to be able to perform a certain kind of an action. So if you look at this, it's a simple protocol, which is a packet internet grouper, and it's giving us all those scenarios. That is one, the format of replying. For example, you're able to see it's replying for us, ping that particular device with this number of bytes of data. It gives us the different replies, the 4 different replies, the timing for it, the TTL, and of course it provides us the statistics of that kind of pinging. Okay, if it was lost, for example, in this case, like earlier cases that you have seen here, again, this is a response. This is how it responds. Okay, If you are connecting to maybe to an internet outside there, it also gives you the request timed out again, and so on and so forth. So anyway, this is what I wanted you to see in terms of a packet internet dropper. It's a simple protocol which checks the communication between two devices. And of course, in terms of the format, in terms of syntax, semantics, and of course the timing part of it is well displayed in this section here. So in protocols, of course, those are very important for us to check. So every protocol that you have, it will always have these three major elements: the syntax, the semantics, the timing of that particular protocol, and of course, the timing here will give you, for example, the data sent and what, and also the speed and even the timing for it to have occurred. So that is what I mean by the elements and the various elements of a protocol. And with that, it brings me to the end of that particular lecture, which focuses on the introduction bit of data communications and networking. Is there any questions so far? Any questions? Yeah, Mina, yes, it is. It's a loopback. Ah, thank you. It's actually loopback. Huh? Yes, it's loopback internet protocol. Thank you. I'd forgotten that that whatever. Yes, it is. It's a loopback. Okay. Any other questions? No questions? Hakuna question yote ama watu wameshiba? Okay, so you can continue. What's the time today? Oh, 6:41. I still have some more time to go. Okay, so let's go on. So allow me now to look at the various models which are used in networking. Okay, so I'm basing it on one of the books that's by Fuzan. Okay, so I don't have to edit this works. So it's basically focusing itself on the different models. Of course, the models help us to understand what how data actually moves between the devices. At least so far, you have seen how data is the introduction bit of it. Okay, now this brings in the aspects of the different models in terms of how data moves from one machine to the other, and it focuses itself on the networking model. Basically, in networking, we look at these models in terms of the layered protocols. Okay, we look at it from the point of how does data move from one level to the other, or from one machine to the other. And of course, it brings in the aspects of that communication between the devices. So we use the concept of layers, and of course, these layers brings us into how information travels from one machine to the other. But of course, it's very fast, so you'll not be able to say that it's this particular stage and all that. So you're looking at it in terms of different protocols at each layer, and of course, looking at it in terms of the way each of these functions. So we are going to talk about the sender, receiver, and of course the carrier hierarchy. Of course, before we can get ourselves to the point of looking at the different models, that is important. So I'd like to look at this case scenario here. Okay, and we have the sender, and of course we have the receiver. Okay, so the sender is going to write a letter, put it in an envelope, and drop it in a mailbox. Okay, so I want us to look at it from a real life scenario. Look at it. I'm sure some of us nowadays they use phones to date. Okay, to date your friends and all that. Your WhatsApp will become your dating platform. At times you'd use emails. No, not emails. Sorry, letters. Okay, how many of you have ever written letters to your girlfriends? I can see here only gents. Are you gents here? There's no lady here. Oh boy, this class is really deprived with gender equity. Anyway, let's go on. So let's look at this. So you have somebody sending a letter. So you have to write a letter, put it in an envelope, and of course drop it in a mailbox. And of course somebody else comes and carries that letter from the mailbox to a post office. And then in the post office, of course, you have to arrange them, sort them out, and of course it's delivered to the post office that you had stated. That's on the lower layers. So the transportation here takes place using the vehicles or even the airplanes or even the train, gets to the other post office. Okay, the other post office again takes the letters, sorts them out, puts them into the mailbox, okay, of the recipient. The recipient goes to pick the letter from his or her mailbox, and of course they read the letter. Okay, if it's a reply again will also be done like the way the sender also did. So if you look at it from that particular perspective, there are different stages of how this communication is taking place. Okay, from the point of writing to the point of receiving of the letter itself, it has gone through different kind of stages. So even in networking or event data communication, communication also takes it in form of layers, from the very top layer all the way to the lower layers, and again from the lower layers all the way to the upper layers or to the higher layers. So in 1947, there was an established institution, the International Standard Organization, which thought of how would we standardize the communication that takes place between connected devices. And for them, they looked at how, for example, the normal environments do communicate, like just mentioned here in terms of writing of letters. And they came up with a framework, and this framework is what is commonly known as the OSI model, or the Open Systems Interconnect model. So it was first introduced in the 1970s with the aim of standardizing how connected devices in the network will be able to communicate. And of course, if you want to create an application, it must be based on these layers of communication. So therefore, the model itself provides us with what we call a layered architecture and provides us with a scenario of what we call a peer-to-peer process of communication, okay? And of course, hiding information behind the scenes and providing the data towards the recipient, okay? And of course, the sender from the recipient, so sorry, the sender to the recipient, and from the recipient to the sender. So basically, the model itself provides us with those aspects of, sending and receiving data across a network from a layered perspective, like the one that I've just shown you here. So let's look at these 7 layers. Okay, so the 7 layers have, we start from the lower layers to the middle layers, and of course to the higher layers. So the middle layers, we have what we call the physical layer, the data link layer. Middle layers, we have the network, transport, and session layers. Then of course the upper layers, you have the application, actually the session. The middle layers are network and transport, whereas the upper layers are the session, presentation, and application layers. Now, for us to be able to remember these layers, of course, we have an acronym. For example, you can say from 7 to 1, we have all people seem to need data processing. Okay, so from top to bottom, we have it as all people seem to need data processing as one of the ways through which you can, manage to remember about the 7 layers of the OSI model. So these 7 layers, okay, these 7 layers, you can focus on them in terms of this drawn OSI model. Okay, it provides us with the protocols, or shows us how the protocol is connected, okay, with each other, or each layer is connected with each other, and of course what normally happens between the devices as the transmission is taking place between the communication between the devices. So in this case, we have application layer, presentation layer, session layer, and how it is interfacing. So when you see, for example, 6.7 or 7.6 in this case, what it does is that connection between the different phases. That's the connection between the 7th layer and the 7th layer and the 6th layer. An interface that between the 6th and the 5th layer, like that, okay? So the communication, of course, starts from the device from the top there. So whatever application that you're going to create or to have, for example, you are talking about an email, for example, okay? The email itself is going to be communicated by the application layer, like an email system, like Outlook, for example. That information will be presented to you on your screen. You write an email, and then you send it. So the moment you send it, it goes through all these layers towards the physical layer, and then again to the recipient, to the physical layer, towards the application layer. So from a different or from a very simple terms, is that we are talking about from 7. Actually, this is how the data moves from the most closest application is the closest to us all, which is the application layer, and the most distant layer is the physical layer. So the layer which combines the cables, the connectivity, and all that is the farthest of them all from our system. But because most of us will be able to handle the cable, that would mean that you are closer to the cable as opposed to the application. No, the application layer is the one which is much more closer to us compared to the physical layer. Now, if you look at this scenario, of course, it's what this all normally happens. Okay, so you have some data, okay, and of course it moves from level 7, which is the highest level, comes all the way up to the lowest level. The lowest level looks at the data itself in form of zeros and ones, not in form of just the text that you've already written, okay? So then after that, it takes through the transmission medium, for example, the cables and so on and so forth. So here is, in form of zeros and ones, and up again all the way to the top there, which becomes the data that you actually had before. Now note here, we have at D2 here, we also have the transmission number 2. Okay, in this case, it's a section whereby you check for errors and of course check for all this communication taking place between the two different layers. So there's that action, and of course the data again moves from one level to the other. So we want to look at what we mean by the different layers of the OSI model, and of course their functionalities and how they perform their work. So in this case, in terms of the layers of the OSI model, as I said earlier on, they are categorized into 7 layers. The physical layer is the first one, okay, data link layer, network layer, transport layer, and of course the session layer, presentation layer, and of course the last one, which is the application layer. So let's see what each of these layers is about, their functions, and of course we also look at it from the point of what protocols are involved in each layer of the OSI model. So if you look at the physical layer, so the physical layer is charged with the responsibility of transferring data in form of zeros and ones, okay? Now, it connects towards the transmission media, and of course the transmission media is able to have the data in terms of zeros and ones from the sender towards the receiver, okay? So the physical layer is basically responsible for the movement of individual bits from one hop to the next, okay? So in this case, it provides us with that transmission of data between point A all the way to point B. Now, the data link layer uses what we call a frame, okay? That's data that is used in the frame. In the physical layer, we normally use what we call bits. In the second layer, we also have to call what we mean by a frame. So a frame here has different kind of components in it. Okay, it has, for example, data showing where the information is coming from and where it's headed to, and of course it has the data itself, and of course any data that's meant to for correction purposes and so on and so forth, especially after encoding of the data. Okay, so basically this layer here is charged with the responsibility of ensuring that the data itself is secure, and of course it's error-free before it is transmitted. So it's responsible for moving frames from one hop to the next. And of course, we need to understand what these frames are, and of course, the structure of frames as it moves from one level to the other. Okay, so this is what I mean by hopping. So hopping means you, for example, you're talking about from one system to the other. So data will move from one particular location, gets to another second level. For example, from the system towards a router, from a router to another link, like that. Okay, until it is delivered to the end system. So if, for example, the distance between your end system to the other system was a little bit far, of course, you're going to go to different hops, okay? Of course, do that to be able to tell exactly how many hops that the data has been transferred from one level to the other, okay? So in this case scenario, means is that data has to get from one stage to the other. It has to be hopped. It has to, like, you're hopping on stones as you cross a river, okay? So it's like you hop until the data get to the very end. So initially it came as like the way you're seeing from point A, but from point B to point F, of course, you're able to see what's happening, meaning it's subdivided into smaller frames because now being transmitted via a link until when it's again assembled back to the end system where it receives the information given to you. So then we have the network layer. So the network layer here is charged the responsibility of ensuring that the data is delivered, okay, from point A to point B, and of course it has what we call the packets. Again, we shall look at the frameworks or the we are going to look at the structure of these packets, and of course we have the data itself, okay, and of course other information within the packet like the source address and destination addresses. And its main purpose is to be able to deliver of individual packets of data from the source to the destination. Of course, here is going to be based on the IP addresses. Okay, of course, you're going to talk about IP addresses later on. And of course, here we talk about the IP addresses, which identifies, for example, how data is being moved from one location to the other to be able to provide that service. So in this case, you have packets, okay, from one end to the destination. And of course, the way it was before, it's subdivided into various small packets of data for transmission purposes until when it gets to the destination, when it's again assembled back for transmission purposes. Now, someone may ask me, for example, is there a difference then between network and, of course, the data link layer? Yes, there's a difference. Network has to be in charge, or its responsibility is to check and see that the data has been received to the other end. Okay, it has been delivered. When you look at it from the point of from the point of network layer, of course, with that, it's about delivery. The other part is about error correction and checking, for example, each and every information is corrected. So they work hand in hand to ensure, as much as there's a delivery of data, the data itself is also it does not have errors. And of course, it gets to the destination as it was supposed to be. So as data moves, the network layer and the data link layer have to work hand in hand to ensure that there's error correction in case of anything. And of course, it gets to the destination as supposed to be by the end of the day. So then we also have now the other layer, which you call the transport layer. Now the transport layer here, it defines means of delivering of this kind of data. Now this means that from one end, data comes from the session layer towards the network layer, and of course from the network layer gets to the other network layer to the other side of the recipient in this case. So the transport layer, its main aim is to decide how data will be transported. As the name suggests, is the transmission of data from one level to the other. So basically, it's meant to deliver a message from one process to another. And of course, its major task is also to ensure it is delivered with the correctness it deserves. So any particular reliable processes, you have to work with these two layers, especially in terms of a network layer and of course the transport layer, to ensure that the data is successfully transmitted towards one level to the other. So in this case, it provides us with that connectivity that the data is going to be transmitted from one level to the other. Then you have the session layer. The session layer creates what you call a session. Like now you're in session. We are now here doing data communication between 5 to 7, for example. That's a session, okay? So it's a window. It creates a window for data transmission between point A to point B. So its major purpose is to create a synchronization, meaning that it's synchronizing each process as it's being transported. Okay, there's that delivery of data from one level to the other. So the session layer creates that particular session to enable one to transmit the data from one point to another. So it's also meant for direct control and of course synchronization, apart from ensuring that there is that part of controlling or having the data or creating sessions that are going to be used for data transfer between the levels. And of course, we do have the presentation layer. The presentation layer here has a way of formatting the data, how it's supposed to be before it can be viewed in the application layer. So the purpose of the presentation is to decide the structure and of course the way the data is being transmitted across the network. So in this case, it's responsible for the translation, compression, and of course the encryption of data. Now in OSI model, there are two layers which are charged with the encryption. The second layer, which is the data link layer, and of course the sixth layer is also charged with the purpose of encryption, of course decryption of data, as data is being presented towards the end of it. So here we have the application layer, which is the topmost layer, and its purpose is to be able to present to us in form of a program or in form of how data is being presented to us on the screen. For example, like when you open the website ai.ac.k, you're able to see those stories moving from maybe one end to the other because it has already been presented. It has half a format. So the purpose of the application here is to ensure that that format is now adhered to, and of course it's provided with a way that is going to be presented to you as a user on the screen. Okay, so the application is basically responsible for providing services to the user, and these services could either be internet service like the web browser, or email systems like Outlook or Gmail, for example, or Yahoo, for example. All those services that will provide you, or all those applications that provide you with accessing the internet services, is basically found under the application layer. Okay, so the application layer is one of those layers that very closest to us as users to be able to interact with the internet services, to be able to provide a communication of our scenario. So in terms of summary, this is what you're able to see from bottom to top using the bottom